So yesterday we converted coordinates from rectangular to polar and vice versa. Today we're going to convert equations back and forth. So recall, meaning we already know this because we did it yesterday, x equals r cosine theta, y equals r sine theta. And we're going to use those same things. We're going to convert in the same kind of ways. They are just equations, not coordinates. So if we have this rectangular equation, x equals -3, we know that that's a vertical line through -3. But we want to convert it, so we know that x equals r cosine theta equals -3. And just like most of the time when we have rectangular equations, we're solving for y. Not every single time, but most of the time, or if you're choosing, you're going to solve for y instead of x. We're going to solve for r. Okay, so when you have this, we're going to solve for r. So I'm going to divide both sides by cosine theta. So r equals -3 divided by cosine theta. What is the reciprocal of cosine? Secant. So this is -3 secant theta, and we have converted. And if we graph this in the polar coordinate system, we will get a vertical line through -3. Well, there's not really a -3, but we good? Okay. So on number 2, we are going to go ahead before we start substituting, and let's get rid of this fraction. We'll multiply both sides by 3. So we get 3y equals x times the square root of 3. Okay. So now I'm going to substitute for y and x. So this means I have 3r sine theta equals r cosine theta times the square root of 3. Right. Since I'm simplifying, I can divide both sides by r, and those cancel out. Then I'm left with sine and cosine. What can we do with sine and cosine? We could make tangent. So I'm going to divide both sides by cosine to move this over here, and I'll get 3 times sine theta over cosine theta equals square root of 3. Now, we're supposed to be solving for r, but our r's are gone. But remember that we had equations that were just r equals and just theta equals. So at this point, since r is completely gone, we're solving for theta. So I can change sine over cosine into tangent, and then I can divide both sides by 3. So I'll end up with tangent theta equals the square root of 3 over 3. So theta equals the tangent inverse of the square root of 3 over 3. And we have no quadrant information here because we're not actually solving an equation. I mean, we're solving an equation for a variable, but we're not really trying to just get a value in the end. So we just take the pure inverse, and if it's positive, it's going to be in the first quadrant. When is tangent square root of 3 over 3? Pi 6. So theta equals pi 6. Okay. And we know that that is one way to graph a line in the polar coordinate system. Everybody okay with all that? All right, good deal. So let's look at number 3. We have y equals x squared. So if we were to graph that in the rectangular coordinate system, what would that look like? What is that? Come on. It's a quadratic. So it's a what when you graph it? It's a parabola. You'll know that. Good Lord. Okay. So it's a parabola. But I'm going to start substituting now. So y is r sine theta. Since this is x squared, it's going to be r squared cosine squared theta. Okay. So I'm going to divide both sides by r. And so that r goes away and one of those goes away. And since I'm trying to get r by itself, I'm going to divide both sides by cosine squared theta. So I'll get sine theta divided by cosine squared theta equals r. What is sine over cosine? Tangent. So I can make tangent theta, but I would still have one cosine in the denominator there. What is 1 over cosine? secant. So r is equal to tangent theta, secant theta. And because this would graph a parabola in the rectangular coordinate system, this would graph a parabola in the polar coordinate system. Okay? Everybody okay with that? So on number 4, I'm going to start by multiplying both sides by 5. So we get 5x equals y squared. You work on that one. So I got 5 cotangent theta times cosecant theta. Let me know if you have any questions about any of that. Okay. All right, good deal. So one of the things that we wrote down, so yesterday we used our little triangle in the first quadrant and we came up with r cosine theta, r sine theta. And we also had that x squared plus y squared equals what? R squared. Okay? So if that is true, which it is, then when I have this in number 5, bless you, x squared plus y squared equals 16, what can I replace x squared plus y squared with? R squared. So r squared equals 16, and we're done. Okay. Now let's look at number 6. Number 6, if I move the y squared over, I'm going to have x squared minus y squared equals 1. Is that going to give me r squared? No, that's totally different. So here we're going to have to substitute. X squared will be r squared cosine squared theta minus r squared sine squared theta equals 1. Remember that our goal is to get r by itself. So what do you think I could do next here? Factor out the r squared. Very good. So I'm going to factor out the r squared. That leaves me with cosine squared theta minus sine squared theta, and that equals 1. Now I know that cosine squared plus sine squared gives me 1, but we're not adding there. Does cosine squared minus sine squared give me anything? Cosine 2 theta. Very good. So I get r squared times cosine 2 theta. So if you can look down at those double angles and see where she found that. And then still trying to get r by itself, so now I'm going to divide, and I will get r squared equals 1 over cosine 2 theta. What's the reciprocal of cosine? Secant. So r squared equals secant 2 theta. Any questions at all? Because it's acceptable to leave it squared. So here, it might be helpful because then we get r equals 4, and that's an easy circle. But it's okay to leave it like this, too, and just figure it out when you do that. And then here, it just makes it worse. Okay, good question, though. We good? Okay. Number 7. Okay, so I have this binomial squared. In order for me to, it would be way easier for me to square it out now than after I substitute. So I'm going to square it now. It is not x squared plus 1, right? It is x squared plus 2x plus 1 plus y squared equals 1. Okay. So I'm going to go ahead, and we know that x squared plus y squared gives us something, right? So I'm going to leave the x squared plus y squared on the left-hand side, move everything else over to the left. So when I subtract 1, those zero out, and I'm going to have a negative 2x over here. Hi. Okay, thank you. Okay. I don't think it's telling you to go right now, but I was trying to figure out. Okay, what is x squared plus y squared? R squared. And then I would have a negative 2 times r cosine theta. Everybody with me? So now I have an r here and an r squared here, so I can divide both sides by r. And that leaves me with r equals negative 2 cosine theta. This graphs a circle, so does this. Okay? Everybody okay with that? All right, let's just go ahead and do this one together. So I'm going to multiply these out. I'm going to have x squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 5. Okay, so I see an x squared and a y squared again, so I'm going to leave those on the left, move everything over to the right. So I'm going to have x squared plus y squared equals, well, 5 minus 1 minus 4 zeros out. So then that'll just give me 4x minus 2y. What is x squared plus y squared? R squared. And that's equal to 4 times r cosine theta minus 2r sine theta. Trying to get r by itself. What do you think I should do on the right-hand side? Factor out r. Very good. So r squared equals r times 4 cosine theta minus 2 sine theta. Then at this point, I can divide both sides by r. This cancels one of those out. So r is equal to 4 cosine theta minus 2 sine theta. Okay. What questions do you have? All good? Okie dokie. All right. So now we're going to convert the other way. We're going to have polar, and we're going to convert it to rectangular. So we're recalling the same things, except that we wrote these in a little bit of a different way yesterday, which will be a little bit more helpful. We know that, so x squared plus y squared does equal r squared, and that was clearly helpful there. But we also know that r is equal to the square root of x squared plus y squared. And we know that theta is equal to the tangent inverse of y over x. Okay. So same thing, you know, as these right here, but that's going to be a little bit, and that's what we were using at one point yesterday, and what will be helpful here. So we're going to convert the equations from polar to rectangular. So r is this right here. This is what I substitute in. Instead of r, I have the square root of x squared plus y squared. That equals 7. I don't want to leave a square root in there, so I'm going to square both sides, and I get x squared plus y squared equals 49. Easy enough? Both of those, graph circles. All right, so now I have theta equals 2 pi thirds. So theta is the tangent inverse here. So instead of theta, I'm going to have tangent inverse of y over x equals 2 pi thirds. Okay, so I need to get the y over x out of that tangent inverse. So the opposite of taking the tangent inverse is taking the tangent. So when I take the tangent of both sides, I will get y over x equals the tangent of 2 pi thirds. Okay. What is the tangent of 2 pi thirds? Negative square root of 3. Very good. So y over x equals negative square root of 3. Let's solve for y. Multiply both sides by x. And I get y equals negative x times the square root of 3. Or a negative square root of 3 times x. But you got to be careful with that so it doesn't look like your x is under the square root. It's kind of safest always to put them last, but it's correct either way. Any questions at this point? Okay. So, number 11, I have r equals 3 secant theta. If I substitute r with this right here, that's not going to get rid of my theta. Like, I got to get rid of the r and the theta, right? So, but I do know that secant is the reciprocal of what? Cosine. So I'd like to get it out of the reciprocals at first anyway. So r is equal to 3 over cosine theta. So then I can multiply both sides by cosine, and I get r cosine theta equals 3. Well, can I substitute something for r cosine theta? X. So I get x equals 3. This is a vertical line through 3, and so is this. Just a different way to graph it. Okay. We good? All right. So then r equals negative 2 cosecant theta. So we'll do r equals negative 2 over what? Sine theta. Good. Multiply both sides by sine. So r sine theta equals negative 2. And what do I replace r sine theta with? Y. Y equals negative 2. Okay. Everybody good with that? Okay, so let's look at 13. If I replace r with the x squared, square root of x squared plus y squared, I have the same issue. I still have a theta. If I divide both sides by sine, I will have r over sine theta instead of r sine theta. So there's not really a way for me to manipulate that easily like I did up here to be able to just get that. So instead, when you have that situation, we're going to multiply both sides by r. So I want you to write it down this way this first time. R times r equals r times 2 sine theta. So you can look back and remember where it came from. We're multiplying both sides by r. It's keeping our equation balanced. It's totally fine. So I end up with r squared equals 2r sine theta. Now I got stuff I can substitute, right? For r squared, I can substitute x squared plus y squared. That's going to be equal to 2, and then r sine theta is y. So I don't have to solve for x or for y, but I've got to clean this up some. We basically want to take this equation and make it look like what these did up here. Okay, so that's when the completing the square comes into play. We're going to move everything over to the left, and x squared down here is just x squared, but then this is going to have to be y plus or minus something quantity squared that we have to come up with. So I'm going to have x squared plus y squared minus 2y plus something, I think Delta Math calls it your magic number, equals, once I subtract that over, I have 0 plus that same magic number. Okay, I get that magic number by taking half of this and squaring it, and I get 1. And so if I add 1 to one side, I have to add it to the other side. That completed the square for me, so now that I have x squared plus y minus 1 squared equals 1. And that's your circle. Okay? What questions do you have? Okay, let's try this last one. So same thing, I'm going to have to start off by multiplying both sides by r. I'll skip this step right here, but again, I just want to make sure you knew what was happening here. So this will give me r squared equals negative 6 r cosine theta. So r squared is x squared plus y squared equals negative 6x. So this time, y squared is just y squared, and I will have a term that's x plus or minus something squared. So I'm going to have x squared, I'm going to move this over, plus 6x, plus something, we'll figure that out in just a minute, plus y squared equals 0 plus that same thing. To get that magic number, I take half of this and square it. That gives me 9 over here, so I have to add 9 over there. That makes all of this become x plus 3 squared plus y squared equals 9. And that's your equation. What questions do you have? If you multiply both sides by r, if you can't substitute anything in to make it make any sense. Like if you have a sine theta and you can't divide or like manipulate your equation to get an r sine theta out of it, then you're going to have to make it into r sine theta by multiplying both sides. Like here, I didn't have r secant theta, but once I put cosine down here and I multiplied both sides, then I had an r cosine theta, because you have to have both pieces in order for it to be x or y. Does that help? It's a good question. Anything else? All right, so your assignment is on a worksheet that I'm about to give you and informative so you can check yourself.